Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, we discuss about the next subtopic that is measures of dispersion. So in this video, we focus about to find variance and standard deviation for both ungroup and group data. So as you can see, the linear outcome for this video, we find variance and standard deviation for ungroup and group data. However, about the PSM coefficient or skewness, we'll discuss about this in the next video. Right. So what is a dispersion? So dispersion, in other words, refers to variation. So it is about how the data is spread out or dispersed from the mean. So the smaller the dispersion values, the more consistent the data. Or in other words, the values are close together. However, when the dispersion values are larger, the data are more spread out. So this means that the data is less consistent. Right, so this is mean, as you can see, the different color. So the blue color, the high value of the mean, but the dispersion is less compared to the magenta color here. So it is more spread or more dispersed. So in other words, it will be less consistent. Right, so let's take a look about the example here, comparing the marks of the math quiz for class MS1 and also class MD1. So as you can see here, we arrange the data according to the ascending order, and as you can see, MS1 got the higher mark. They have 10, 12, and 15. However, as you can see here, the MD1, even though not many students have higher mark, but the most of the score students are closer to the mean. Okay, so it's not doesn't necessarily the higher mark will be the better. If we discuss about in terms of dispersion or the consistency, so as we can say that the MD1 is better in terms of the less dispersed and more consistent, right, compared to MS1, which is more spread out. They can have as low as a 3 mark, and they can have as high as the full mark or the 12 marks. Okay, compared to MD, most of the students have the mark more or less closer to the mean. So maybe, as we can guess from here, so the mean is somewhere around 8. Okay, so 7 and until 9, so these are closer to the mean. Right, so this is the two quantity that we will use to discuss in this video. That is, the first one is about the variance, and the other one is standard deviation. So for variance, I think you may already learn a basic of what is the variance in your secondary school. However, in your secondary school, the formula is actually a bit different from here. It is because the formula that you learn in the secondary school is purposely for the population. However, in our cases here, it is we focus about the sample. So this is a sample case compared to the secondary school. So secondary school is more about the population formula. And as you notice here, the notation also different. We use S squared for the variance compared to the secondary school. The formula for population, we use sigma squared. Okay, so the notation also different to distinguish between the population cases and the sample cases. And the one that not change is the standard deviation, because we know the standard deviation basically is a square root of the variance. This one is not changed. Okay, I already mentioned earlier. So this is the formula regarding sample cases. So remember, for sample cases, the significant one here, we have n minus 1 at outside. Okay. Right. So now look at the example 19 here. So in this example, find the variance and standard deviation of all the following numbers. So start from 6, 7, 10 until 25. Right, first of all, how about this data? Is it group or ungrouped? Yes, of course, since we don't have table and class interval, so here represent the ungrouped. Okay. So for the ungrouped, this is the formula. Remember, as I said earlier, the formula we have n minus 1 outside. And we have to find out the sum of x squared and the sum of set x, and then we square over n. So what is the number of n? So we can count the number of n here. But before that, as I said earlier, we have to find out the sum of x and the sum of x squared. So we list out the x and the x squared. Okay, so this is the x, 6, 7, 10. So and then we squared the x, so we got 36, 49, 100, and so on and so on. Okay, so at the bottom here, the below here, so we had the sum of x. So the sum of x here is 117. Where in other hand, the sum of x squared will be 1801. And the number of n here, we can count out the number of n here. So we find out the number of n here is 9. So we already have all the information, the sum of x squared, the sum of x, and also the n. Then we can substitute all this into our formula to find the variance. So remember the notation of x squared here. So it refers to variance. Okay. So 1 over n, which is 9, 9 minus 1. So this is sum of x squared. And then the sum of x, we need to square, divide by n, that is 9. So press in your calculator. Then you find out the sum of, the value of the variance will be 35. Okay. Right. So next, the standard deviation. Right, as I said earlier, the standard deviation is basically the square root of the variance. So we square root the value of variance, that is 35. Then we can obtain the value of the standard deviation, which is 5.916. So remember, usually for the standard deviation, because later on maybe you will need to find the PSL coefficient or other parameter after this. So basically for standard deviation here, we give in 3 decimal places. Okay. So that's the example about the ungrouped data. So this is an example for the group data. So notice here we have a class interval. So this is for the group data. So the data below represent the numbers of kilometers that 20 runners ran during a week. Find the variance and standard deviation for the distribution. Right? So from this table, remember, from the class, we have to put many columns. So as you can see here, this is the table, this is the formula, and this is the table. So in order to construct a table, you have to check the formula here. What is the parameter that you need? So compared to the ungrouped data, for the group data we have f that multiply together with x squared and x here. Okay, so we still have some x squared outside, but now we have to multiply also with f. So same also inside the square here. You for ungrouped it is sum of x, right? So also here we have to multiply with f first. And in this case, x refers to the midpoint of the class interval. So remember how to find out the midpoint from each interval. So this is the midpoint. This is already given the frequency. So we just multiply f with x and then we get fx. So below here we sum all of this fx. So we got sum of fx. So this 490 we substitute inside the square here. And then notice outside here, we have to find out the sum of fx squared. So in order to make easier, so why not we put a column for x squared. So from this x we squared. So we got this x squared. And then we multiply f with this x squared. Then we got sum of the f of f and x squared. So below here we can sum of fx squared. So we got 13,310. So this value will substitute out at the front here. So this is how we before that, just to remind of you, the formula here we have n. So this n actually refers to the total frequency, okay, which is 20. Okay. Now we substitute all these values into our formula. So remember n is sum of the total frequency, that is 20. So 20 minus 1, and then inside here 20. And then sum of fx, so we put inside the square here. And then outside here it is sum of fx squared, which is 13,310. Right. So press your calculator and you will get the value of the variance. Remember x squared here represent the variance. Is 68.68. Okay, then we square root the value of the variance, then we can get the standard deviation. So remember, for standard deviation, as I said in the previous example, we give the answer in 3 decimal places, that is 8.287. Okay, right, I think that's all for the example regarding the find out variance and standard deviation. So stay tuned. In the next video, we will discuss about the Pearson coefficient of skewness. So until then, thank you very much. Bye bye.